Leslie from period 5, and today I'll be teaching you how to find the slant asymptote, vertical asymptotes, and holes for a given equation. My equation is x cubed minus 2x squared minus 3x over x squared plus x minus 12. And you can obviously tell that we have one bigger degree on top than we do on the bottom. So that should already indicate to you that we're going to have a slant asymptote, and we're going to have to do long division in order to get it done. So here's my long division work. I have the x squared plus x minus 12 on the outside and x cubed minus 2x squared minus 3x on the inside. So as you can see my work, we don't care for the remainders, So we end up just having x minus 3, and we're going to have it in the y equals mx plus b form. So basically our equation is just y equals x minus 3. So once you get that done, we're going to move on to the vertical asymptotes. And we have to factor our original equation, which should factor to x parentheses x minus 3 x plus 1 over x minus 3 x plus 4. And in order to find the vertical asymptotes, we have to set the bottom equal to 0. And since basically the x minus 3 x minus 3 cancel out, we are just left with x plus 4. So we set x plus 4 equal to 0, and we get x equals minus 4. And our equation is basically x equals minus 4. And if you plug in the original equation into the calculator, so this equation with parentheses, you should get something that looks like this. I know it looks funky, but on a different calculator, maybe you have the more high-tech ones, it should look different. But this is what this calculator showed, which basically just means, as x approaches negative 4, that's a negative right there. F of x approaches negative infinity. As x approaches negative 4 to the right, f of x approaches infinity. And now we're going to move on to see if we have holes. And we do, because these two cancel out. So basically our holes are anything that canceled out. So we have x minus 3, and we set it equal to 0. So you add 3 on both sides, x equals 3. And then you have to plug in the 3's into the x's. And so then we plug in the 3's to the 0, so you should get 3 plus 1 over 3 plus 4. We are not plugging it into the things that cancel out, because obviously they cancel out, they're not there. So we should end up having 12 over 7, and that should equal 3. So our point is 3 comma 12 over 7, and if you want to simplify it, I guess, or put it into decimal form, it should be 1.7. And now we're going to move on to our domain. And we get our domain from our two x's, which is negative 4 and 3. So these are our two numbers that we're going to work with. So it should be negative infinity comma negative 4 unison, negative 4 comma 3 unison, 3 comma infinity. So yeah, and x-intercepts, y equals 0. So basically here we are working with the top. So we automatically know, since there's an x on the outside, one of our points is going to be 0, 0. So then we're left with x plus 1 equals 0. And obviously that turns into negative 1 over 0. So those are our 2 points. Now we move on to the y-intercepts, which is x equals 0. And we're only going to plug in the 0 to where all the x's are. So we should get 0, 0. And basically we should just have 0 over 4. Remember, it's not 1 because 1 times 0 is 0. And that's basically nothing. So one of our points is going to be 0, 0. and we're going to move on to our key points. So I divided this as the line. So we're going to look from anything on this side as 3 points and anything on this side as 3 points. And remember, when you're graphing, to mark your vertical asymptote and your slant. So your vertical should be on -4 and your slant should be on -3. It should look something like this. So then I picked 3 random points, and they were pretty big numbers. So I had to make room over here, but it should look something like that. And then I picked other points on the right side of the vertical line, and my graph ended up looking something like that. So basically, that was me working out my problem. Thank you for watching, and have a great day.